Hello and welcome. My name is Bronwyn. I am a chemistry tutor at the Tutoring and Academic Skills Center at COD. You can come and ask me chemistry questions. Tutoring through COD is always free, and there's a tab for it on your Canvas homepage. What I'm here today to help you with is making the most out of your chemistry textbook. So let's go ahead and get started. In the inside and back front covers, there's often information. So you've got the periodic table, that is almost universal among books. For this particular book, they also have a list of functional groups. And then in the back, it has a list of common abbreviations, arrows, and symbols. So what's included in your specific book is going to depend on what your course is covering. You may not have the exact same thing, but I would encourage you to just take a look. The next thing that I see students really not make use of, and whether it's because they don't know how or they're not even aware that it's here, doesn't really matter. I'm here to help you with it. The index is where to find information on a ton of different topics so that you're not having to go to the front, find which chapter may or may not contain what you're looking for, and then try to leaf through the whole chapter and find it. That's a very inefficient use of your time. And if you're like me, you're a busy student. So what you do is you go through here and you figure out, okay, what do I need to look up? So in this case, I want to know about Bronsted and Lowry acids. So I would look under A and then through, okay, acid is right here. And then there's also acid and base reactions as well. So Bronsted and Lowry is listed once under acid, and it's listed again under acid-base reactions, and it has the page number next to it. So both cases, it was pages 60 to 62 and page 265. So I'm going to go to those pages, and that will have my information there for me. Now, your textbook may not have things filed under exactly what you think of it as. So perhaps I thought, oh, it's going to be under Bronsted and Lowry, right? So I'm going to look under B and then I don't find it. And then I think, well, this book just doesn't have it. No, you have to sometimes think of it through different perspectives and say, okay, Bronsted and Lowry, it relates to acids. Let me look under acids. Then you find it. So don't assume that if your first try is not successful, that it's not in here. You may have to rearrange your thinking, I guess, and figure out what other ways it could be listed. So next is the glossary. The glossary is the mini dictionary of your course. So things that are defined throughout the book will also be defined back here. This particular book actually lists the section number that you'll find the topic in. That's not universal. So let's say you are attending a lecture and your professor talks about aldol condensations. You can go back here and say, okay, what is that? Oh, okay, it's an initially formed beta hydroxycarbonyl compound. It loses water by dehydration. Okay, what the heck is dehydration? Go back here. Dehydration. Reaction results in the loss of the elements of water from the reaction. So you get the idea. You may have to look at multiple definitions to get the big picture, but it's almost all of it is going to be included here if it's included in the chapter. So the next part are the different appendix or appendices that you're going to find. Now, depending on the content of your course, what will be in the appendices will be different. So don't assume because you don't see this that you don't have them. This particular book, it includes pKa values, which relates to acids and bases, how to do naming. So this is important because naming is covered early in the book. So you'd think, okay, well, we'll just look at that chapter. But as you learn all these different functional groups for this course, there's naming for each one of them. And there's naming for different shapes of compounds and things that have double bonds versus not double bonds. This will summarize all of that very quickly. So you can look at it when you're getting ready for an exam. So the appendix is helpful throughout the course, but it's especially helpful when you're studying for midterms or finals because it has everything in a very small condensed form. Next, let's talk about how to read a book. So if you're getting ready for a lecture, let's say it's Monday and your lecture is tomorrow morning. You don't necessarily have to read the entire chapter before the lecture. Some people do that. If you do that, that is great. Don't stop. If you are really busy, maybe you are working and you've got kids, or you're just someone who really enjoys learning from listening to the lecture, then what you can do instead is look at the end of the chapter for the chapter summary, or sometimes it's called like here key concepts. And this will cover just a basic overview of everything included in the chapter. So this includes all of the reactions that we'll see, structures and properties, and then there's also problems. So you don't have to sit and do these problems because, again, you haven't learned this content yet. But what you can do is just spend a minute or two looking through and getting an idea of what type of problems you're going to see either in your lecture or on your homework or on a test. So you can kind of prime your brain for what you're looking for. Then if you have time, you can go to the beginning of the chapter and just look at the subject headings. So, okay, introduction, who cares? No offense. But the subject headings will give you a general idea of what's going to be included. So, okay, so there's chain growth polymers involved. There's some reactions here for radical polymerization. So, okay, radicals are involved here. There's chain branching. Okay, so the structure of the alkene portion, that's going to matter in some way. So as you're looking through this, the goal is not to sit and just read the whole book. The goal is to get an idea of what's included and to think back through content you've already looked at, either in a previous course, earlier in the same course, or even just life experiences you've had that are related to the content that you're seeing, because that will make it more meaningful and also, quite honestly, less boring. So an example of that would be, there's a chapter on alkanes early in the course. So maybe you're an engineering student and you're interested in engines and fuels. Well, there's several examples in there that talk about fuels and cracking and what causes knocking in an engine, for example. So maybe that's something that you slow down and read a little bit more about. It might not show up on a test, but it helps you engage better with the material. So after the lecture, you've taken all of your lecture notes, you can go back through and then start looking at the chapter itself versus your notes. So is there anything in here that gets explained in greater detail that's helpful for you? Cool. Is there anything that the teacher completely skips 100%? Chances are that's not going to be on a test, just from the instructors that I've had anyways, where you can always ask the instructor, hey, I saw this in the book, do we need to know about this? And then, they'll just tell you. So you just go through. Again, the purpose is not to take a whole nother set of notes. What you want to do is just annotate or add to your existing lecture notes. The other way to do this is if you are the person who really reads the whole chapter before the lecture, is to take your book notes, but just space them out some. And then as you go to the lecture, add the lecture notes to your book notes. So one way or the other, you're going to have one condensed set of notes. Lecture notes with some book notes added, things that weren't covered or things you found interesting or equations, or book notes, and then you add the lecture notes to it. You don't want to spend time taking two sets of notes and then writing a third condensed set of notes. Like, very few people have that kind of time. My best friend does the all book notes and then added lecture notes. That's her way. And then I do lecture notes and then I add a little bit of stuff from the book. That's my way. So they're both opposites, but we're both, A students. So you don't have to do things one specific way. Whatever helps you gain access the content the best, that's the way you got to do it. And then as far as working through problems, whether it's in the book itself, like if you're assigned problems, or if it's on a worksheet, I encourage you to skip around and do different types of problems. So for example, if you're in a chapter about naming, they might have naming rings, naming things with different functional groups, naming if there's a double bond on it versus not. That might not apply to your specific class, but the idea will be the same. You can start to feel comfortable if you do a lot of the same type. You want to do enough that you see the pattern start to emerge, but not so much where your brain is just running on autopilot, because at that point you're really no longer learning. This is something Professor Flora talks about in her math courses as well, so it's not specific to chemistry. But the majority of where good grades on exams and quizzes and stuff come from is from you doing lots and lots of practice and getting lots of things wrong, quite honestly, and struggling sometimes, and that's okay. So if you're working through a problem and you get stuck, just do your best to get as much of the problem done. So maybe you only get 70% of this one and then 60% of this one, and then, maybe like as you look, you look back through your notes, look through your lecture note, you text your friend, okay, I'm getting 80%, 90%, I got 100% of this one, great. Once you reach that point, stop and do another type of problem, and then another type of problem. So repeat that process. And then the ones that you got stuck on, take that work to tutors, to your professors, to your classmates that you see are doing well, and have them explain to you the nuances that you're missing. But you don't want to just get to the point where you're just stuck and you stop. So just do the best that you can on as varied a number of problems as you can, and you will get the most out of your class and you will get better grades. There is kind of a perception among students in general, not just chemistry, that going to lecture should be enough to get A's. That is really not the case. Going to lecture is just the very bare beginning of what you need to be successful academically. One of my teachers explained it as being sort of like a tour guide. They're there to introduce you to the world, and now it is up to you to explore and ask for help if you get stuck. So you want to make sure that you are utilizing whatever resources are available to you, whether it's, within your book, for example, if your book has answers at the back, doing like all the even ones that they have answers for and then checking it, or using, like I said, the index to find content within your book. YouTube lectures, tutoring center, going to office hours, all of those things are going to be necessary to be a successful student. There's no one thing where if you just do this, you're like guaranteed an A. It just doesn't work like that, especially in chemistry, because it uses so many different skills. You're going to need to be able to do some amount of math depending on the level of your class. You're going to need to be able to do a little bit of memorization, but not a lot. So if you're someone who has always relied on flashcards to get through courses, you may use flashcards like very minimally, like maybe 10% of the content, but the other 90% is practice problems, practice problems, practice problems, practice problems. I will say it again, doing practice problems. So rework problems that your teacher gave in lecture and try to cover their answer and try to match their answer as well. Do problems out of the book. If they provide worksheets, do those. So just do as much practice as you can. And if you are trying to think 3 steps ahead and figure out what the answer is going to be, like stop. Okay, that is something that I'm very, very guilty of when it comes to doing homework, and it's something that had to be like almost beaten out of me. So one example of that is with resonance. If you are taking Chem 5 through Chem 10A or Chem 10D, and there's some in 1A and 1B as well, you'll learn about this concept of resonance, where you're not literally moving electrons around, but on the paper you're going to be moving them around. I would often try to say, okay, well, this won't work because 5 steps in the future, it's going to run into like a brick wall. But that wouldn't always work because there would be things that I couldn't see that far ahead. So when you're in doubt, just put pencil to paper, even if it's wrong, just do it. Just like rip the Band-Aid off and do it. You'll hear me say that a lot if you come to tutoring, just do it. Because 9 times out of 10, you will realize partway through why it won't work. And that is the most helpful knowledge, like running into those boundaries where you start to understand, oh, I can't go that way because this won't work. Like a more general example is if you're doing problems where you have to get a positive value out. So you do that whole problem and you get a negative number. Okay, well, that's why I can't do this way, because it gives me a negative number and it has to be positive. So that's my suggestion. how to make use of your book, how to make the most use of, doing homework problems. If you have any questions, talk to your instructors. You can come and talk to me. There are tutoring and academic skills coordinators as well, and many of them have, master's degrees and can definitely help you as well. So I hope this was helpful, and best of luck on your courses in chemistry.